Now for video help with problem 8.6. Actually, in looking at what I wrote out here, and again, I'm going to scan these and send these to you, all of these notes, so you can follow along. You don't have to copy anything down. And also remember to read the written homework hints. Looking through my notes here that I made for this video, I realize I'm telling you everything, but there's so many important points that it's a price I'm willing to pay. And I'm sorry to ruin the problem for you. So we have two pi pulses here, and we order the times just so we can have an echo with a single pi pulse if it's a time tau at 2 tau. And my ADC represents, remember, analog to digital converter. Analog meaning we have a voltage that we measure from those receive coils. And of course, we digitize everything. We have a relative peak then, 2 tau later, an echo. But you remember that what it is that we can't recover everything. You remember what we've got is the actual 1 over T2 stars, 1 over T2 prime plus 1 over T2, and we can recover this part corresponding to inhomogeneities and say due to external field, but we can never recover the intrinsic T2 because that's due to things that are fluctuating in time, and the delta B's from this are changing in time, and they aren't staying, constant in time as we go along here, and we cannot then cancel them. So while we can try to recover, this full decay due to the T2 prime and the T2 mechanisms, the external and the internal, we always have this overall T2 decay that happens, and we can't get rid of that. Nevertheless, it's important that we can recover part of it. See, it's dying, but then we rephase it, and they come back together, give you a relative maximum, and then they're dying. Oh, but if we put another pi pulse, then we can rephase them. They'll come back together. But remember, I've got that overall envelope killing me. And I have these multiple pi pulse sequences. Well, the first time through, it's pretty easy. We had M0 from our magnetization. We tipped it. We've got a pi over 2, half the size here. We tipped it, and we got M0 then in the transverse plane, and it, of course, decays according to T2 at this time, and then it's still decaying a little more. And so this is our signal, relatively without factors, at the 2 peaks, of course, decreasing. But the next time through, we're going to repeat this every TR. So we've got NTR for n equals 1, 2, 3, ... We need to know, hey, how big is MZ the next time? Because we had M0 at first. But what's MZ now after TR? So that what can we do to, what do we got left to tip something? Well, what happens, of course, is if TR were really big, we'd get back to full recovery to M0. But TR is not. We are considering pretty large TR, but not that large. At TR, we're going to consider TR on the order of T1. So it's not too big. We don't have complete recovery. How do we figure out recovery? Here's that master formula that we use over and over again for the longitudinal part of the magnetization. We have that at any given time t, if nothing else is going to happen after this t0, we have some value at t0. We got the initial condition, the initial value, times the exponential, plus m0, the recovery piece, 1 minus e. So that t minus t0 means we can start the clock at t0 or anything we want. But here's what makes this problem really easy. Tau is tiny compared to T1. T1 and TR are about the same size. That means e to the minus tau over T1, that's practically 1. And e to the minus 3 tau over T1 is still, practically 1 also. We still consider 3 tau small compared to T1. So it's as if the 2 pi pulses happened right close to t equals 0. And as far as recovery goes, this time is so small that there's almost no recovery there. And so we almost as if we're starting right at the beginning and we just have full recovery. That's 0 to begin with. We just have this term. We just get mz of tr as m0, 1 minus e to the minus tr over t1. That's what we get back here. This junk that happened at the beginning happened so soon that m sub z stayed 0 throughout all of this. And it started practically at 0 and then recovered. See, it's practically 0, and then it just recovers according to that. So to repeat, it is as if the 2 pi pulses happened at t equals 0 as far as recovery goes. And we get just mz tr is m0, 1 minus e to the minus tr over t1. And that, you'll just replace these guys by that, and that's your signal. That's the same thing every tr, because the next time we tip this, we have no mz initially. It doesn't ever change much in this small tau story, and it recovers again just according to this. And so I get this term every time at the end of every tr. The whole story is identical after the very first time. So we repeat. It's like the story on the page 130 or whatever for around equation 8.41. If you want to kind of just, for your own muscle building, look at how I would calculate this thing carefully and write things out step by step between these 2 pi pulses and after it. Look at my homework hints and you'll see what the formulas sort of look like. But afterwards, when you have tau small, it all collapses just to that.